Black holes are a one-way street. You go in, and nothing escapes, not even light. In Sagittarius, there is a black hole that weighs 2 to 4 million times the mass of our Sun, and we on Earth are actually moving around that black hole. If you thought you knew what black holes are, prepare to have your mind blown. There's just no good end to anything that falls into a black hole. There's a lot more that happens in those things up in outer space, and fascinating new details are being revealed to this day. More recently, researchers in Russia have made some of the scariest discoveries ever. Join us as we unravel what Russian scientists discovered inside a black hole that terrified the whole world. The common, more fictional concept of black holes is that there's some sort of portal to another dimension. This has been proven wrong many years ago, and what scientists have discovered may send shivers down your spine. According to researchers at NASA, black holes are mysterious entities of space with a gravitational pull so strong that even light can't escape. Something that scientists thought was impossible turned out to be true in 1915 when Carl Schwarzschild found the solution to Einstein's equations predicting the phenomena of black holes. But it wasn't until later, in 1964, when Cygnus X-1 was discovered and something that was just a theory turned into a physical entity that revolutionized astronomy. Cygnus X-1, this special black hole, is 15 times heavier than the Sun. It also has a companion star for easier identification. This binary star system is a very strong source of X-rays and is considered the first major evidence to prove the existence of black holes. It sits approximately 7,000 light-years away from us. The fact that scientists discovered something so far away in the early 20th century is by far the most interesting thing scientists have found. Fast forward to the 21st century, we've discovered over 100 million black holes within the Milky Way galaxy. Since these things are invisible and a lot bigger than the Sun, their existence is a terrifying thing to consider in the cosmos. Now, the question that was on every researcher's mind was how these things form in the first place. Since there's no life, gravity, or air in outer space for basic chemical reactions to occur, how do black holes appear in the universe? There are generally two pathways that scientists have studied: stellar corpses and direct collapse of gas. Stellar black holes are born from the remnants of massive stars that slowly lose all the energy in them and collapse under their own gravity. Direct collapse of gas, on the other hand, can lead to the formation of more massive black holes, most of which are supermassive ones. Now, there are two different pathways after gas clouds collapse under their own gravity. The first pathway of cosmic evolution begins with the life cycle of a massive star. The initial masses of these kinds of stars are around 8 to 10 times that of the Sun. When stars shine brightly, they fuse hydrogen into helium in their cores. Once the nuclear energy finishes, it collapses and triggers a catastrophic event known as a supernova. Here, the outer layers of the star are released into space in a violent explosion. Because it's outer space where you can't really hear anything since sound can't travel there, these supernovas could happen without you even noticing it. Once the supernova occurs, one of three things is formed: either a neutron star, a white dwarf, or if the star is massive enough, a black hole. Believe it or not, if a supernova occurred as far as 65 light-years away, the cosmic rays and aftermath would risk humanity as we know it. At least 30% of the ozone layer all around the planet would be completely destroyed, 87% of it would be destroyed in polar regions. Coming toward the second pathway, the direct collapse of massive gas clouds skips some of the stages of star formation. In regions of space with high densities of gas and dust, the different gravitational forces can cause clouds to collapse as well. The difference here is that a protostar is formed. In some special cases, the gravitational forces are so strong and intense that even a protostar isn't formed. Instead, the gas cloud collapses and directly forms a black hole. Another question that's often asked is how long these entities last. Do black holes lurk in distant galaxies forever, or do they eventually die and leave something much more terrifying? When they form, they can live for potentially billions or even trillions of years. Their gravitational pull has been felt at every corner of the universe for a very, very long time. With this pull, they draw close gas, dust, and even stars. These things are usually drawn in groups and clusters, which eventually form a disk. So what happens when the so-called disk exists? Think of it like a Death Star that shoots high-energy radiation like X-rays and gamma rays. But that's what happens to the things around the black hole, right? What happens to the actual black hole? Many scientists believe that black holes are considered to be eternal. Once they're formed, they'll exist forever. The only thing that slows them down or makes them fade away is the emission of all those gamma and X-rays from the makeshift Death Star. Stephen Hawking helped coin this theory in the 1970s. Hawking radiation was named after a brief quantum study of black holes. As the Hawking radiation is emitted over time, the black hole slowly loses mass and eventually dies. Let's talk a little more about Hawking radiation to get a clear picture. These come from quantum fluctuations near the event horizon, where pairs of particles spontaneously pop into existence. To make things simpler, think of these particles as bubbles in a fizzy drink. They appear out of nowhere, completely unpredictable. They also come in opposite pairs called antiparticles. When they meet, they cancel each other out and disappear forever. It happens so fast, it's as unpredictable as them appearing in the first place. Sometimes they'll appear on the event horizon, and if one of them falls into a black hole, the other escapes into space. Because of strong gravitational forces, the one that's trapped in the black hole has some of its energy stolen from the void itself. The stolen energy piles up, which causes the black hole to lose its mass. In a nutshell, this process is what we call Hawking radiation. So black holes aren't just for swallowing anything within their vicinity, they also release this Hawking radiation. The phenomenon helps scientists understand the lifespan of a typical black hole. The smaller the mass, the more rapid the Hawking radiation and the shorter the lifespan. It also helps scientists differentiate between black holes and wormholes because these two behemoths of space aren't as similar as one may think. The concept of black holes and wormholes, unlike black holes, which are regions of intense gravitational force, wormholes are hypothetical tunnels in spacetime that connect two distant points. Now, this may sound very fictional and something you'd see in movies or hear in storybooks, but scientists are trying their best to figure out their existence, and they seem to be making breakthroughs year by year. It all dates back to Albert Einstein's theory of general relativity. Scientists have been studying these things since what feels like the dawn of time. Einstein published his theory in 1915 and expanded it 10 years later. His theory suggested that relativity argues with the concept of space and time being unrelated to each other. So, by definition, a wormhole is considered to be a tunnel from one place in space to another. If you were to place an object in spacetime, it would create a curvature of the spacetime in the nearby region. This theory has been used in many science fiction movies, but the problem is that scientists have never proven its existence. Black holes, on the other hand, have been found and photographed using event horizon telescopes. The theoretical entry of a wormhole is two-sided. Again, they're similar to tunnels with one way into a different point in spacetime. Black holes have an event horizon. This means that if something enters this region, it's stuck in the black hole for eternity. The only similarity between black holes and wormholes is the influence of different masses. The mass of the object affects the size of the curvature in spacetime in the case of wormholes, while it affects the energy released from black holes. NASA might end up making a telescope specifically for wormholes, just like the Event Horizon Telescope. This depends entirely on how technology will change in the future. We've already launched a telescope that can basically turn back time. Yes, the James Webb Telescope has made some very interesting discoveries that will blow your mind away. The possibility of an image of a wormhole would change the course of astronomical sciences forever. But as far as space discoveries go, wormholes are unfortunately out of the question. What was discovered, though, is something that blew away many scientists all over the world. But before diving into the specifics, you should also be familiar with some of the black holes that have already been discovered. The first black hole captured, Messier 87, also known as M87, is probably one of the most interesting discoveries made to date. It's actually a supergiant elliptical galaxy in the constellation Virgo containing trillions of stars. It's also one of the most enormous galaxies in the universe. 55 million light-years away from us is M87, which also emits radio waves in the universe. It's no wonder why astronomers are enchanted by something so magnificent. It was first acknowledged by Charles Messier in 1781. The technology of this era was almost non-existent to make any detailed observations, so M87 wasn't fully understood until much, much later. 2 centuries later, Heber Curtis observed a jet-like feature in the core of M87. This was the first identification of an extragalactic jet. What's an extragalactic jet? It's like a stream of radiation emitted from the core of certain galaxies. These jets are basically like the polar opposite of a black hole. They emit radiation in high-energy particles in the form of synchrotron radiation. This is another phenomenon that may be very hard to understand. Basically, it's a very high-energy jet that emits radiations ranging from radio waves to X-rays and even gamma rays. It's named after the synchrotron, which is a particle accelerator that generates similar high-energy radiation. But if there's a lot more energy within this, how could it be the opposite of a black hole? To answer this, the jets emit a very high percentage of radiation into space. Black holes just swallow anything within their vicinity, and most of the radiation ends up within the gravitational pull of the black hole. The emission jets are located at the poles of the black hole, so if you're thinking about traveling from one place to another in space, it would be the best place to be in. Most of the energies are away from the jet. The central region of M87, a very bright core emitting radio waves, is the biggest piece of evidence that scientists have found regarding the existence of a black hole. It's considered a supermassive black hole, roughly 6.5 billion times the mass of the Sun. Its event horizon spans over 20 billion kilometers. The discovery of this black hole was a monumental step in the field of astronomy and gave the scientific community insight into the nature of black holes. This discovery also paved the way for many researchers to study the behavior of black holes and their surroundings. Now, even more recently, there have been many other black holes that have been discovered. Even a black hole in the center of our own Milky Way galaxy has been found. The discovery of these cosmic giants isn't just limited to galaxies far away. This next black hole discovery is so massive, you won't believe it. This is the discovery that Russian scientists made, and it's terrifying.